Okay. So this time we're going to discuss limits of functions, numerical approach, or numerical introduction of limit. So another way to introduce the concept of limit of a function, sorry. So again, another way to introduce the concept of limit of a function is by investigating the values of f of x near x equals a numerically. So let us consider the following functions. So we have number one, so again, in this is finding limits of functions numerically. I think my computer has a problem now. It's still blinking. Finding the limits of functions. Sakit sa ulo. Blinking, nagbi-blink. Finding the, parang ilaw na nagpapatay sindi. Finding the limits of functions. So it means kung hindi nagbi-blink sa inyo, ang problem is my computer. Paano na yan? Finding the limits of functions numerically. Okay, guys? Okay, so investigate or examine the behavior of the given function near x equals a, where x equals a will be indicated numerically. Numerically. Okay, guys? Number one, let's say the given function is f of x, and that is equal to x squared plus 2x minus 3 all over x minus 1. I want it to be near x equals 1. Okay? So let's now have some values. So I'm going to prepare a table of values. X, then f of x. Okay, guys? Now, but for simplicity, let's simplify the equation. I think the equation, it can be simplified. Anyone who wants to simplify the equation, guys? F of x is equal to x squared plus 2x. Mr. Officer,
Yes po.
you can call a name if you want. You can simplify this right side. What is the factored form of the numerator?
X plus 3 is multiplied with x minus 1.
X minus 1, x plus 3.
Yes po. All over
And
x minus
then
1.
x minus 1. I can cancel this out, no?
Yes po.
We can cancel that because after all, we are not interested with x equals 1. What we are interested near x equals 1, but not really x equals 1. Is that okay, guys?
Yes po.
So this is equal to x plus
X
3.
plus 3.
As long as what? As long your x is not equal to 1. Okay? The reason why we have near x equals 1 but not equal to 1. So I'm going to assign values of x close to 1 but not equal to 1. First coming from the left and then the other one coming from the right. Okay, let's have first coming from the left. So this is now my table of values. I'm going to have another like this. Copy. Then another here. Okay. I'll be ready with your calculator. Let's say I'm going to assign close to 1 but not equal to 1. Let me start with 0.9. Then 0.99. Then 0.999. 0.9999 and so on. So let's see what we can get. So here you want x less than 1. While in the second one, x greater than 1, but close to 1. Let's say 1.1, 1.01, 1.001, 1.0001. Okay, guys?
Okay po.
So let's check that. Let's see if there is a number, evident number that is being approached by the function as we have our x gets closer and closer to 1. If x is 0.9, what is the corresponding value? What is f of 0.9? So you can compute it from x plus 3 rather than from this quotient for easy computation. After all, this f of x which is equal to this quotient is equal to x plus 3 as long as your x is not equal to 1. Is that clear, guys? So 1.9 plus 3. What's the answer? 3 point what? Guys,
3.9.
3.9. What about if 0.99?
3.99.
3 plus 3.3 plus 0.999. 3.999, no? And you see the trend. 3.9999. Or what do you think? It will what? It will go to
4. It approaches 4.
as x approaches 1, it will approach 4. Okay?
Okay
So
po.
again, as x approaches 1, it will approach 4. This is not actual 1, approaching to 4, approaching 1. So approaching 4. So we conclude that as x approaches 4 from the, approaches 1 from the left, what is happening to f of x? approaches 4, no? Or equivalently, limit of f of x, that is this quotient, as x approaches 1 coming from the left is equal to 4. Okay? What about coming from the right? 1.1 plus 3. It's 4.1, right? What about 3 plus 1.01? 4.01, no? Then we have 4.001. Hi guys, do you know what I am doing? I am substituting this value to what? To x plus 3. And I'm trying to determine what value it being approached, no? So approaching what? As x approaches 1, so this value is what? Approaching, no?
4 as
Approaching
well.
4 also, no? It
Opo.
seems that the decimal part is disappearing, eventually negligible until it has no practical value anymore, the decimal part. Okay? So we'll have approach 4. So as x approaches 1 coming from the right, f of x is approaching positive 4 also. So we can conjecture that, or we can say that as x approaches 1 from the right, f of x approaches what? 4, no? Meaning that's the limit. So do they have the same behavior from the left, from the right? So same limiting
Yes po.
value is attained. There is a common limiting value. Therefore, we conclude that the limit is what? Of f of x as x approaches 1 is equal to what, guys? 4. Okay? So the limit exists and it is equal to 4. Is that clear, guys? Guys?
Yes po, sir.
Yes po.
Okay, so let's have number 2. Hi. Okay, so let's have number 2. Again, let's prepare a table. So, and first let's have function f of x. And I want the function to be, let me have a function. I prepared a function here. Let's check this one. 1 over x minus 3 quantity squared. I want the behavior near x equals 3. Ay, blinking. Could you please stop? Nako, ayaw stop ng blinking. Sira na yata the computer of mine. So we now have let's now a table of values. So let's say we have x less than 3. I have this table of value x f of x. Let's start with close to 3, no? From the left. So let's start with 2.9. You can have 2.8 if you want. Or 2.8. Then 2.9. Then 2.99. then 2.999. 2.9999. 2.9999. Yan. Okay? Dot, dot, dot. Dot, dot, dot. Oh, saan pumupunta, guys? Let's check. 2.8. Oh, could you please compute, guys? 2.8. 1 divided by
25 po.
2.8 minus 3. Square it. Is it what? What's the value, guys? Guys, what's the value did you get? Guys,
25.
25. Okay, very good. What about 2.9? 2.9 minus 3. Square it.
100.
So, ilan? 100.
100 po.
What about 2.99? 1 divided by 2.99 minus 3, quantity squared. Is it 10,000?
10,000.
10,000 po.
Ilang ano yon? Paano yung exponent to the fourth? Na? So what about 2.999?
1 million.
Divided by 2.999 ay tatlong 9 minus 3 quantity squared. Oh, what's the value, guys? Ilang 0? 1, 2, 3, 4, 5, 6. So 10 to the 6 na. Then
Yes po.
2.121 divided by 2.1234
10 to the 8
na
po.
9 minus 3 quantity squared. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8. Is
8
it
po.
8?
10 raised to the 8th power po.
May trend naman, no?
Yes po.
10 squared, 10 to the fourth, and so on. Anong napapansin nyo, guys? As my x gets closer and closer to 3, so let's say getting to be 2.9999, then 9999, and so on. What is the value attained by what? By f of x? Does it attain a limiting value? Guys?
I think it
keeps on
approaches
what?
infinity po.
So it keeps on growing, no?
Yes po.
So as x approaches 2, so it keeps on approaching what? Big number. It's approaching
Professor,
positive
3 po.
infinity, na? Okay? So we say that the limit,
Professor, hindi ba 3 po yung sa x?
sorry, 3. Sorry. As x approaches 3 from the left, what is happening to the function? Approaching positive infinity. Okay? What about if we have same, but this time x is greater than 3? So let's check if we will be getting same values, same behavior. Since this is a squared, so I think you will get the same behavior, no? If I get, for instance, close to 3, but to the right of 3. Ano ba yung to the right of 3? 3.2, 3.1, 3.01, 3.001, 3.0001. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Dot, approaching 3. Dot. So, ang difference niya para sa 2.8 at 3.2, no? Negative lang ang kanilang
Yes po.
okay? So, pag in-square, same, no?
Yes po.
25, naka-square eh. So, this is still 10 squared, right? 10 to the 4th, 10 to the 6th, 10 to the 8th. It tends to go to what? Still to positive infinity. Okay, is that correct, guys?
Yes po.
So, limit, therefore, as x approaches 3 from the right, so of f of x is equal to positive infinity. Okay? You notice that it's easier to read the limit from the graph, no? At least you now have a concrete understanding of the limit. And this is what is happening actually if you assign value. But instead of assigning value, because we have picture already, we are just traveling along the curve, coming from the left and coming from the right to get what? To get into the limit. Okay? But here we are assigning value and we try to find a pattern for the values obtained. So we therefore conclude that the totality, what's the limit? As x approaches 3 of f of x. Sophia Garciano, what's the conclusion?
Positive infinity.
Okay, positive infinity. You have a dog?
Yes,
Sophia,
yung neighbor ko po.
That's your dog?
Hindi po.
Huh? You don't have?
Hindi po.
What dog is that?
I'm not sure po. Sa neighbor ko lang po.
Okay, what I have Saint Bernard and Golden Retriever. Okay, anyway. So that's the limit, no? Positive infinity. But of course, the limit does not exist, no? We interpret, of course, this limit does not exist. Is that clear, guys? Hi, guys.
Yes po, sir.
Sir,
Okay, number
Yes,
3. Let's say my function is f of x is equal to then we have it is square root of 4 minus x if x is less than 0 or equal to 0, and it is x squared if x is greater than 0. Okay? So this is x squared. Let us have 0 to, this is x squared plus 2. Okay? So let's see. So again, solution. Be ready, ha? For x that is to the left ng 0, I want it near x equals 0 this time. Not to 0, ha? Not equal to 0, but near only. So first, let us consider those values of x near 0, but to the left of 0. And the other case, x is near 0, but to the right of 0. So we have x. Then we have function value.
Professor, you have a question in chat po.
Yes. Question in chat. Why not just speak? So that I null instead of D and E. We don't use the word null. Non-existent, we use normally the word non-existent, does not exist, or no limit. May mga book I saw no limit or does not exist. Or if the limit does not exist, some books use the word no limit or non-existent. But I haven't seen using the word null. Have you seen one, Iho? Who gave that? Guys, I do not know. I haven't
Shamil po.
seen one. Guys, did you see a book using the word null?
No. No
In
po.
case you have, I'm not close to suggestion or to what you have. So if you find one, let's see. Okay, guys? Actually, I'm using for definitions and principles, I am using the Calculus 7 by Louis Lighthold. You know, even different calculus books, there are principles that they differ slightly, no? Merong konting difference. Kaya you have to be careful when reading books. What sometimes there is a what you call this? Agreement of the book on the use of the principles. Okay? So you have to check what the agreement of the book. Because if you're, let's say, using that book, so you have to follow throughout. But as I said, I am using Lighthold, and I'm going to agree with you that but let's say although we will be using officially basic calculus for math engaged learning by Nocon, Rui Vivar, and what's the other one? Lim. But when it comes to definitions and principles, I am using the Calculus 7 by Louis Lighthold. Is that clear, guys? Do you know that book? Because that was the book that we were using when I was still in the rival school, when I was still in the Blue Eagle, when I was still studying there. Hi, guys. Clear now? Guys.
Okay po.
So don't use for the meantime the word null because I haven't confirmed that. But if you will able to confirm that to me, so it's all right. But let's agree to use DNE or does not exist or non-existent. You can use the word non-existent. Non-existent. So far, ito yung mga term na nakikita ko, no limit. So f of x approaches no limit. Something like that. So let's see. Let's have a near zero, no? -1. Let's start with -1. Actually, once you define limit precisely, because the word close is vague, no? So how close? What do you mean by close, no? So there is what we call precise definition of limit. If we will have much time, because I think it's not in your syllabus, but if you go to college and you take BS Math or any related field, you will be having delta epsilon. But in our case, I think we will not be using that. Either it's not part of your syllabus. Let's see, I'll be asking some other teachers, no, about that. -0.9. Am I right? -0.9. Negative or negative point close. 0.1 o 0.1 na lang. Negative 0.01. Negative 0.001. Negative 0.0001. I think this is enough to come up. Let's see if we can have a conjecture from this. But what about greater than 0? 1.1, 0.01, 0.001, 0.0001. Oh, could you please give me the values, corresponding values, guys?
Does it need to be in decimal form po?
4 minus 1. Yeah. Decimal. 4 minus -1. Decimal, so that we can approximate we can see the pattern, no? Is it 2.2? Guys? 2.2.
Yes po, 2.23.
O 24. So what about -0.1? 4 plus, magiging plus, no? Square root. 2.02.
2.02 po.
What comes next?
2.00 po.
2.00.
Yes po,
2.1.
2.00 po. 2.00.
4 plus 0.001. Take the square root. 2.002.
Yes po.
Parang may trend na, no? Is it 2.0002?
Yes po, trend is developing.
2.00002? Or what do you notice? It goes to what value? It seems to go to
2.
2, no?
Yes po.
So as x gets closer and closer to 0, the value gets closer and closer to 2. What about here? When x is 1, 3. Am I right? 0.1 square it plus 2. 2.01. Am I correct, guys? 0.01 square it plus 2. 2.0001. Pakicheck nga yung value ko, guys. 0.01 square it plus 2. No?
That's correct po.
0.001 square it plus 2. O the more, no? 2.0001, 1, 2, 3, 4, 5.
Yes po. 5 zeros.
1. And then the last one that I am trying, 0.0001 square it plus 2. Okay. 2.00000. How many?
7 po.
1, 2, 3, 4, 5, 6, 7. How many now? 1, 2, 3, 4, 5, 6, 7, 1. Oh, what do you notice? Actually, from the right, it goes faster, no? Reaching what? Reaching this limiting value.
Yes po.
So, limit as x approaches 0 from the left of f of x, it is equal to what? 2, no? What about from the right?
Same din po.
Same. Therefore, the limit exists, no?
Yes po.
Okay, guys?
Yes po.